All right, the last section here is quantitative electrolysis. So I talked before about how we can use electrolysis to electroplate things or to purify, that's the word I was looking for, any metals, things like that. So we can actually measure how much metal you could plate or how much metal you could purify, or maybe what it was before it was pure by figuring out how much was deposited. So what we have to do is we have to be able to measure the current. So that's the flow of the electrons. We measure current in amps. So whether or not you have taken any physics, amps are what we measure current in. An amp is a coulomb per second. So coulomb is charge. Okay. Second, of course, is time. So it's the amount of charge in a certain amount of time that is essentially running. So you will need this. This is on the equation sheet. If I ask for the watts, watts are related to those electrons moving and whatever that E cell is. So your max wattage for a reaction is negative NFE. That should look familiar. Negative N is number of electrons, Faraday's constant, and your E cell. Okay. We also need to know that 1 watt is the same thing as joule per second. So it's the amount of energy per second. So watts are more related to the amount of energy you're going to get, and amps is related to the electrons. Okay. So these conversions are going to be really necessary when we are trying to figure out how much solid we can electroplate. Okay, so all this is dimensional analysis. So unit conversions, watch your units, get everything to cancel, write out your units when you are doing this. But essentially you're just trying to do a conversion. So it's kind of like a long straight geometry problem. Okay, so example number 13. I'm gonna walk through this one and then you can try 14. So 13 says I've got copper 2+ ions in electroplate out at the cathode. So that means I'm trying to get them to turn into solid copper so I can collect. Okay, so if there are 0.404 grams of the metal are plated out in 5 hours, so after 5 hours, that's how much I collected, then what current was applied? So what current had I used to do this? All right, so let's break it down. I've got copper. Okay, I'm trying to turn it into copper solid. I have 0.404 grams is what I made. Now this is an amount. So if you have like a certain amount, that's what you should start with. That's the easiest thing to start with. And I did it in a certain amount of time. So in 5 hours, I made 0.404 grams. So what I did is I actually started with that as a ratio, how much I made per 5 hours. So 0.404 grams over 5 hours. Okay, so that was like the rate at which it was made. Okay, so essentially I just need to convert grams and hours until I get to current. Current is amps. Amps is just coulombs per second. So essentially I need to convert the grams to coulombs somehow and the hours to seconds. Well, the hours to seconds part is easy, right? Hours, 1 hour is 3,600 seconds. Great. Okay, so now this would give me grams per second. Now I need to get rid of grams. So the easiest way to do that is convert to moles, right? Okay, so I've got mass of copper is 63.55 grams. So I got 63.55 grams copper for 1 mole. All right, now I have moles per second. Now I need to get all the way to coulombs, which has to do with charges and electrons. So this is how these conversions work. I go 1 mole of copper because I need that to go away. Well, 1 mole of copper, to get that, I need to transfer 2 moles of electrons because, right, it was +2. So it's just the number of electrons, the charge essentially that we are trying to change. So 1 mole of copper does 2 moles of electrons. And then we also have Faraday's constant, which is coulombs per electron or mole of electrons. And it is 96,485. That is a constant. Coulombs per mole. So that actually gets me from moles to coulombs, which means now I am just left with coulombs and seconds. So coulombs per second. So if I do all this math, I end up with 68.2 coulombs per second, which is just 68.2 amps. Okay, so whenever we're doing electroplating and we're using masses and time and amps and all of that, these are essentially the conversions you're going to need. Okay, you're going to need the ones I put up here. Amp is a coulomb per second. You're going to need a watt is a joule per second. And you're going to need Faraday's constant in order to get these to convert. So why don't you guys try example number 14. Before you get going, I will tell you that 8.52 milliamps would be like 1,000 of an amp. So there are 1,000 milliamps in an amp. And remember that an amp is a coulomb per second. So give that a shot and I'll walk through the answer. Okay, so I started with 10 minutes. Why did I do that? Well, I started with 10 minutes because if you have like a unit that is something per something, that's kind of harder to start with sometimes. So if you have a value that is just 1 unit, like minutes, I would start with that. It's kind of just a tip, I guess. And a milliamp right? I said there's 1,000 milliamps in an amp, and an amp is a coulomb per second. So it's really like a ratio. Okay, so I started with my 10 minutes. Now the question is asking, it's oxidized the anode, how much iodine is produced? Okay, so I want to get to like grams of iodine. So got 10 minutes. And let's see, I just went ahead and converted that to seconds because I know amps is in seconds. So I have 1 minute, 60 seconds. And then if it was going 8.52 milliamps, that means it's going here, I converted it down here, 0.00852 amps, and an amp is a coulomb per second. So I took this value and I've used it as a conversion factor, 0.00852 coulombs per second. Now my seconds cancel out and I have coulombs. We always use Faraday's constant to get rid of coulombs. It's the only thing that has coulombs in it. So I use Faraday's constant is 96485 coulombs per mole of electrons. Then how many moles of electrons am I trying to change? Well, let's see here. I have iodine. I'm trying to go to I2. I highly recommend writing out the full equation. I didn't, but that's because I need 2 of these to make I2. So I am moving 2 electrons to make an I2. So 2 moles of electrons to 1 mole of iodine, and then 1 mole of iodine to the mass of I2 to 53.8 grams of I2. So it would plate, or it would make 0.00672 grams after you do all of that math. So kind of the key takeaway here, use your conversions. Start with a single unit if you have one, instead of one that is like a rate, like a this per this. And Faraday's constant is what you should use to get away from coulombs or away from electrons.